Miss Moy's classes. Okay, Mrs. K across the hallway. Let's help. Let's make chemistry make sense. So this is from last week, hopefully. Let's review a little bit together. I put it in this ed puzzle so that we can kind of check our understanding and hopefully get us all kind of on the same page. So these should look familiar. If they don't, then fantastic. You get to watch it for the first time. Okay. So here we have a chemical reaction. Let me grab my little marker. So here we have a chemical reaction. We have hydrogen chloride. Oh, here we go. We have hydrogen chloride plus sodium hydroxide. Okay. Now, in my reactant side, I'm going to look at how many atoms I have total. So if I count, I have 1, 2, 3, 4, 5 total. So that tells me I must have 5 total on this product side. Okay? Think about it this way. If I bake a cake, put all the ingredients in a bowl, I mix it together, I put it in the oven. That's my chemical reaction. Those same ingredients, they're going to look different because now I have like a fluffy cake instead of goop. But all those ingredients, it's the same amount coming out. Okay? So 5 atoms go in, 5 atoms have to come out. If I have an example like this, where I now see, okay, I have a purple sodium atom and a green chloride atom already accounted for over here, what has to be left then? We should see that we have 1 oxygen left. Well, that's a weird O. 1 hydrogen and 2 hydrogen. Okay. If you lost how I did that, I looked at my products and I went, okay, there's a sodium, there's a sodium. There's a chlorine, there's a chlorine. What's left? Okay. Now, hopefully we saw it was water. For an example like this, I'm going to do the same idea, but hopefully a little quicker. Okay. I look at my reactants. I have 1, 2, 3, 4, 5, 6, 7 reactants in the beginning. I need to have 7 reactants in the end, or sorry, 7 products in the end. So I'm going to look over here. Okay, great. I got a silver. Take that off. Silver, take that off. Chlorine, take that off. Chlorine, take that off. That means that I have my nitrogen, my oxygen, 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 and this time I get my sodium. Hopefully with me. Hopefully. Okay. So on the test, you're going to see more examples. They're going to look more like this. Oh, sorry, let me resize that. They're going to look more like this, okay? So instead of like atom names, it's just going to be colors because this is 8th grade chemistry. We just need this like base knowledge so that once we get to high school, we can understand what we're talking about. So in my base knowledge, I'm looking at this picture and I see, okay, great. There's a green and a purple and a blue and a red to start. If I have 4 atoms in my reactants, how many atoms do I have to then have in my products? Okay, so 4, right? In my question and Amplify, I know I don't have all the words here, but it says my starting substances have different properties than my ending substances. If my substances have different properties, can they be the same molecule or do they have to be different? They have to be different. If they have different properties, they're different molecules. Like think salt and sugar. Salt and sugar look really similar, right? But salt tastes salty, sugar tastes sweet, okay? Different properties. Salt and sugar have a different melting point, different properties. They're different things, okay? So salt at the atomic level looks very different than sugar at the atomic level. So here, if I say, okay, starting substances and ending substances, all different properties. Can I have an atom that's just a green and a purple then? If I know they're different properties? No, I cannot. So that tells me right off the bat, well, if these have to be different, then I'm looking at my answers. Well, it can't be C, because C is just these exact same molecules, but just flip-flopped. Okay, so it can't be C. And now my question's pretty easy. If I know that I had to have 4 in the beginning, I have to have 4 in the ending. Now I'm just seeing which one has all 4. So D has this extra black one down here that didn't show up in the beginning, so it's not that one. B has a red and a red. I only have 1 red in the beginning, and I'm missing a purple. It can't be that one. So then it has to be A, okay? And I'll double check it. I have my green, green, red, red, blue, blue, purple, purple. Okay, so my answer has to be A. Okay, so if I'm talking about a chemical reaction, okay, can an atom ever magically turn into a different atom? For example, could a hydrogen ever become an oxygen? No. Okay. Could an oxygen become a sodium? No. Okay. Hydrogen is always going to be a hydrogen, and oxygen is always going to be an oxygen. They're just going to rearrange and make different molecules, but they're still the same. With me? Hopefully. Okay. So my next question here. Okay, this time it's giving me properties, okay? So this one's saying my starting substances, my reactants. This first mystery one is a white solid. It boils at 800 degrees Celsius. My second reactant is a colorless gas. It boils at 70 degrees Celsius. My products, colorless liquid, boils at 245 degrees Celsius. Are my properties the same or different? Okay, they're different. So are either sample 1 or 2 here going to look like this molecule, yes or no? No, because my properties are different, so it can't look like this. This is a little tricky question. Up here, we have to read the words carefully. It says an ending substance. That means one ending substance. This question means there is another ending substance. So if I draw it like this, plus another ending substance, hopefully that makes more sense. I don't need to know what this one is. I can figure this out. I already said, okay, they have different properties, so it cannot be this molecule. Okay, great. It cannot be D. Can't be D. That one doesn't work. And now I'm just going to go through and check, well, if these 4 in the ending substance, it has to be somewhere in the beginning. I need to find A, B, or C that has a purple, blue, pink, and a yellow. Okay? So if I look at A, I am missing my blue in A, so it can't be this one. For B, I'm missing my yellow, so it can't be that one. For C, let's double check. I have a purple, I have a blue, I have a pink, and I have a yellow. They're all there. This is also telling me that this mystery substance here, okay, we'll get rid of that question mark. This has to be a green and a purple, because that's what's left over, a green and a purple. Okay? So we should see that it's C. Okay, with me, hopefully. So this one, a little quicker. Okay? Move my face out of your way. Here's my starting substances. What are my ending substances if I tell you the properties of all 4 substances are different? They're all different properties. What is my ending substances? A, B, C, or D? What do you think? Okay, hopefully we saw and we paused our video that we could see it has to be A. A has all 4 present. Okay, B has an extra one. C, it's the same ones over again. And D has 2 greens and is missing my purple. It has to be A. Okay. What about this question? Are these the same substance? Okay. Are these 2 samples the same substance? Sample 1 and sample 2. So look at our colors. Do you think these are the same? Yes or no? These are not the same because sample 1 has 3 greens and 2 oranges. Sample 2 has only 2 greens and 2 oranges. That yes, they're the same color, but they have a different number of atoms connecting to make the molecule. Okay? I could say this example would replace the greens with hydrogen and the orange with oxygen. Okay? If I have an extra hydrogen in sample 1, that means it has to be a different molecule. It means it has to be a different substance. Now, it also does not matter if I have 3 molecules here and 5 molecules here, right? That doesn't matter how many there are, doesn't make it different or the same. How many there are decides how much I have. So if I have 3 molecules here, and this is a liquid substance, that would be a small cup. But maybe this liquid sample over here would be a bigger cup because it has more molecules. They're still different samples. So on your test, if you can figure out, okay, these are different, it's not because there's just more molecules, it's because there's different atoms, different number of atoms joined together. Okay? Hopefully this helps clear up a little bit. Okay, on these slides, these are the chemical reaction chapter 2.1, 2.2, 2.3 slides. If you needed to go back on your own and look at them. You also have key concept number 5, number 6, and number 7 that you can either go look in Google Classroom or I guess you could just pause the video. Okay? Good job. Make sure you finish all of your questions for your Ed puzzle. If none of them made sense, go back and watch it again. Okay? You got this.